Given a 30, 60, 90 right triangle and one side length, can you find all the other side lengths? Here's an example. In this triangle, if we were to finish it off by mirror imaging the triangle back over on itself and make this 60 degrees, this piece here would be a right angle. This piece here would have to be 30 degrees. And what kind of special triangle is this? This is an equilateral or equiangular. If this side is 4, this side must be 4. In other words, the whole length around the whole triangle is 8. So y for this example would be 8, which is opposite the 90 degrees. What would x be? Well, to figure out x, we could do the Pythagorean theorem where the hypotenuse is 8, or 8 squared, we know, would equal the squares of the sums of the legs. Solving for x squared, 64 minus 16 is 48. So we have x is the square root of 48. And we want to figure out how to simplify 48. If you think about the factors of the biggest perfect square in 48, 16. 16 times 3. So what's the square root of 16? It's 4. So x would be 4 root 3. In this example, we have 5 as our length opposite the 30 degrees. If you imagine again taking the extending this right triangle to be an equilateral equiangular, we know the side opposite the 90-degree angle would be 10. What would the side opposite the 60-degree angle be? If we mimic the example up here, well, this was 4 root 3, so maybe this should be 5 root 3, but just to prove it to ourselves, let's go ahead quickly and do it. We would have 10 squared equals 5 squared plus x squared. 100 equals 5 squared, or 75 equals x squared. X equals the square root of 75. Biggest perfect square in 75 is 25 times 3 would give us 75, so it would be 5 root 3. In general, in a 30, 60, 90, the hypotenuse is always 2 times the smallest angle, the smallest side. In this case, the hypotenuse would equal 2a. The bigger leg, which is the side opposite the 60 degree, is a, which is the length of the smallest side, times root 3. So in the below example, we have a 30, 60, 90 here. We know this has to be the 30 degrees. Again, the side opposite the hypotenuse is always the smallest leg times 2. So x would be 70, and y would be 35 root 3. In this example, the side opposite the 30, the smallest leg is 5 root 2. What would be the hypotenuse, which is y? It would be 2 times 5 root 2. 2 times 5 root 2 is 10 root 2. Now we have to figure out what x is. X equals a root 3, which is the smallest side times root 3. The smallest side, the smallest leg is 5 root 2 times root 3. So the answer here would be 5 root 6. I'll leave C for you to do at home, and we will check it next class. The top of the next page has some more examples. Let's do example A, which looks a little different, where we have the side opposite. Well, actually, this one is pretty straightforward, so I'll have you do this one. Let's do B. The side opposite 60 degrees is 9. So 9 is what we think about as A, which is the smallest leg, root 3. 9 equals A root 3. Actually, you know what? Let's call this not A. Let's call this X root 3. Because X is opposite the 30 degrees. We want to solve this out by dividing both sides by root 3. And we rationalize the denominator by taking out the root 3 in the denominator by multiplying it by 1. And so the denominator would be 3. The numerator would be 9 root 3. It's taking out a 3 in the numerator, and in the denominator we would have an answer of 3 root 3. So X is 3 root 3. Y, the hypotenuse, is twice the smallest leg. So 3 root 3 times 2 would be 6 root 3. Complete C on your own, and we will check it in next class. Here's some examples using both properties. The 30, 60, 90. And this triangle is a 45, 45, 90. So for this triangle to the left is the one that we'll have to use because that information will transfer us over to here. So if this is a 30, 60, 90, the hypotenuse is twice the smallest side. The hypotenuse is twice the smallest leg, so X must be 5. So this is an isosceles right triangle, which means that both of these are 5. It doesn't ask for this one. Y is the hypotenuse of a 45, 45, 90. From last class, we learned that it should be 5 root 2. The hypotenuse is root 2 times the sides in an isosceles right triangle. Looking at this crazy picture over here, we have a 45, 45, 90 isosceles right triangle. And we have to come up with the dimensions of this 30, 60, 90 one up here. So we know this is 6 and this is 6. This must be 6 root 2. So the side opposite the 30 degrees is 6 root 2, the smallest leg. So the side opposite the largest, which is the hypotenuse, would be 12 root 2. And the side opposite the 60 degrees is 6 root 2 times root 3, 6 root 6. Please finish C and D, and we will discuss it next class.